In this video, we will be solving a system of equations in 3 variables. The way we do that is we start by eliminating a variable using 2 of the equations. Then we eliminate the same variable using 2 different equations. Obviously, one of them will be the same, but then choosing the other one. And using those 2 new equations we've created and eliminating a third time to solve for one of the variables. So what does all that mean? Let's look at these. I'm going to go ahead and label these 3 equations as 1, 2, and 3. So this is equation 1, this is equation 2, and this is equation 3. The first thing we have to decide is which variable to eliminate. Technically, you could start with any of the 3 variables. Generally, there's going to be one that might be easier than the others. When I look at this, I see that the y's look really nice to eliminate. In fact, I already have a minus y and a plus y using equations 1 and 2. So I'm going to start right there with those 2 by eliminating y. So starting with equation 1, just copying it down exactly as is. And equation 2, I didn't have to do anything to that. So I'm going to copy that down and add them up. Negative 5x, oops, there's an x there, plus a negative 10x is negative 15x. Plus y minus y is 0, that's gone. 5z plus 1z is 6z. And negative 3 plus 3 is 0. So I don't lose it, it still has to equal something. In this case, it equals 0. I'm going to call this new equation equation 4. I still can't solve this equation because I have 2 variables and only 1 equation. So I need a second equation to be able to solve that. Since I've used 1 and 2, I can't use both of those again, but I could use one of them. I'm going to go ahead and keep equation 1 because it has the negative y, and now add that to equation 3 because it has the positive y. I could also choose to do 2 and 3, but then I'd have to multiply 1 by a negative to get that plus and minus y. So using equation 1, copying it down, I didn't have to multiply by any factors here. And then equation 3 this time. 20x plus y plus 2z equals a positive 3. Alright, 20x and a negative 5x would be positive 15x. Plus y minus y, that's 0. 5z plus 2z is 7z. And negative 3 plus 3 is also 0. I'm going to call this one equation 5. Now that I have equations 4 and 5 with the same variables, notice I had to eliminate y and then eliminate y again. I couldn't choose to eliminate x, that wouldn't do me any good, because then I'd have an equation with x and z and then a different equation with y and z, and that wouldn't help me. I need to eliminate the same variable twice, and now I have 2 new equations with those same variables left over, x and z. And now I'm back to where I was before this section. I'm solving a system of equations with 2 variables and 2 equations. We can use elimination or substitution, just like we learned before. In this case, I already have a positive 15 and a negative 15, so I don't have to do any work. This does not always happen that way. Generally, you're going to need to multiply to get your variables to eliminate. But for now, I can just take equation 4, which is negative 15x plus 6z equals 0, and my equation 5, which was a positive 15x plus 7z equals 0. So this is my new system here. 2 equations, 2 variables. It was already set up nicely for me to eliminate. So I'm going to have negative 15x, positive 15x is 0. 6z plus 7z is 13z. And 0 plus 0 is 0. Now I have one equation with one variable. I can get that variable alone by dividing both sides by 13. So z equals 0. Sometimes you might think that this is a mistake, but it's not here. You can get 0 as part of your coordinate. So our coordinate is going to be an ordered triplet, x, y, z. This is 1/3 of our answer. We need to find the rest of it. Now that I have z, I can plug that into either equation 4 or 5, because if I plug in for 0, now I can find x. It does not matter which one you choose. I'm just going to go ahead and choose 5 because it had the positive values. So let's see, 15x plus 7z was 0 equals 0. Anything times 0 is 0. Then I have 15x equals 0. Divide both sides by 15. 0 divided by a number is still 0. You might stop and say, wait a second, this can't be right. I have 2 zeros. No, just keep going. Let's see what else we can get. We have x, we have z, now we need y. We plug in both x and z into any of the 3 original equations. Again, it doesn't matter which one. You can choose any of these. I'm going to go ahead and choose equation 2 here, only because the y was positive, and that's what we're trying to find is y. So using equation 2, replacing x with 0, I don't know why, replacing z with 0, and equals 3. 0 times anything 0, this is 0. The only thing I have left is y equals 3. So now I have my ordered triplet x, y, z. If I did this correctly, then I should be able to check this, and it needs to work for all 3 equations. Just like in the previous video when we were identifying whether or not a ordered triplet was a solution to a system, you have to plug it back in and check all 3 to make sure it ends up true. So looking at this first equation, x would be 0, this would be gone. Z would be 0, this would be gone. And I'd have a negative y. So negative 3 equaling negative 3. That checks out. If I plug in 0 to the next equation, 0 times anything would be 0, so this x term would be gone, the z term would be gone, and 3 equals 3. That's also true. In the last equation, I'd be plugging in 0 for x, 0 for z. This would be gone. 0 times anything is 0. 0 times anything is 0. And then I'd be left with 3 equals 3, which is also true. So this must be the answer. So if you're ever unsure if you have the right answer, you can plug it back in to double check yourself. Alright, let's go ahead and try this next example. Again, I'm going to start by labeling them. This is equation 1, equation 2, and equation 3. And that's just going to help me keep track of my equations as I solve. I can choose to eliminate any of the 3 variables that I want. In the last problem I did the y. And this one I think I'm going to choose the x. Because of this x right here, it's almost alone. It just has a negative here. But I could just multiply by a constant of 3, and it's going to eliminate with this x. Or I can multiply by negative 4, and it's going to eliminate with this. So I only have to multiply one equation, and I'm going to get what I need for my elimination, versus multiplying 2 equations. Alright, so I'm going to take equation 1, and I'm going to multiply it first by 3. So negative x plus 6y minus 4z, multiply the left-hand side by 3, and the right-hand side by 3. So whatever I do to one side of the equation, I have to do the same thing to the other side of the equation. And simplify. So this is still equation 1, just now by scale, or multiplied by a scale of 3. I have negative 3x, positive 18y, and a negative 12z equaling 9. So that's my new equation 1, just multiplied by a factor of 3. And then the second equation, I don't have to do anything to, because now I have the positive 3x that I need. So I'm just going to copy it down exactly as is, and then add them up. If I did it right, I'm going to eliminate my x variables. Negative 3x, positive 3x, that's 0. 18y plus 3y is 21y. I have a negative 12z, positive 3z. That gives me a negative 9z. And then lastly over here, I have 9 plus 9, which gives me 18. Now, something that you could have done from the beginning is in this equation 2, and notice that everything has a factor of 3 in it. 3x, 3y, 3z, and 9 is 3 times 3. So you could have just divided out a 3 from right there and simplified that equation a little bit. I went ahead and eliminated first, and now that I'm here, I see I've got these big numbers here that I kind of don't want to have to deal with later. So I'm going to go ahead and divide both sides by 3, because everything has a common factor of 3. 3 divides into 21, 3 divides into 9, 3 divides into 18. So all I'm doing is simplifying my equation a little bit. So 21y divided by 3 is 7y. Negative 9 divided by 3 is negative 3z. And 18 divided by 3 is 6. I'm going to call this equation 4. Now I have equation 4. I need to eliminate x again. So again, I like this negative x here because it's easy to multiply and get a way to eliminate the x in this third equation. So now I'm going to take equation 1 again, and I'm going to multiply it by a negative 4. So why a negative? Well, because this already has a negative, I need a positive. So a negative x divided by, or times a negative 4 is going to give me the positive 4x I need to eliminate. I'm going to multiply the left-hand side, making sure I hit all of my terms. It's so easy to lose signs, lose numbers here. So I multiply my left-hand side by negative 4 and my right-hand side by negative 4 to keep it equal. Distributing that negative 4 through, a negative times a negative will end up positive 4x. Negative 4 times a positive 6 is negative 24y. And negative 4 times negative 4 is positive 16z. Negative 4 times 3 is negative 12. And now I'm going to be adding that to equation 3, which was negative 4x, positive 2y, and negative 3z equaling a positive 11. When I add that up, I can see my x's are going to eliminate, which is good because I needed to eliminate the x's again. Negative 24 plus 2 is negative 22y. Positive 16z and a negative 3z is going to give me positive 13z. And negative 12 plus a positive 11 is negative 1. This is now my equation 5. If I could, I would try to simplify this, but I can't. There's no common factors here, so that's as simplified as that equation can get. Now, I am comparing equation 4 and equation 5 and trying to decide which variable to eliminate. I can eliminate y or z, does not matter which one. I'm going to go ahead and choose to eliminate z because they're smaller numbers. I have 3 and 13 here compared to 7 and 22. So I'm going to eliminate z. The least common multiple between 3 and 13 is 39. So I need each of these equations now to end up with a positive 39z and a negative 39z. I already have the minus and the plus, so I don't have to worry about signs. I just have to get that common multiple. So to get 39 for this z in equation 4, I have to multiply both sides of the equation by 13. 13 times 7y minus 3z equals 13 times 6. If I multiply that through, I'm going to end up with 91y minus 39z equaling 78. So this is my new equation 4. If it helps, I'm going to write a new there. And then I'm going to take equation 5. I want this z to become a positive 39, so I have to multiply both sides of the equation by 3. So 3 times my negative 22y plus 13z equals 3 times my negative 1. 3 times negative 22 is going to give me negative 66y, and plus 39z equals negative 3. This is my new equation 5. Now looking at 4 and 5, if I did it right, my z's are going to eliminate. I'm just going to move this one over here. So this was positive 91y minus 39z equals positive 78. Add them up. Positive 91y, negative 66y is going to be positive 25y. Plus minus 39z is 0. Equals positive 78 minus 3. It's going to give me positive 75. Divide both sides by 25 to get y alone. And I get y equals positive 3. Phew! And that is just 1/3 of my answer. So now I have to back substitute to find the rest. So I can plug in this 3 into either equation 4 or 5. I'm going to choose equation 4 because it has smaller numbers here than the 22 and the 13. So moving this way up here, I have equation 4. I'm substituting in for y. So 7 times 3 will equal, minus 3z equals positive 6. So again, just taking this equation here, this was equation 4, replacing y with 3. Multiplying, 7 times 3 is 21. Subtract 21 from both sides to get z alone. I have a negative 3z equals a negative 15. Divide both sides by negative 3. And z will equal a positive 5. Now I have 2/3 of my answer. I take y and z, and I can replace it into any of these 3 equations, right? 1, 2, or 3. I want to find x. I'm going to go ahead and choose equation 1 because it looks like the easiest as far as getting x alone. So in equation 1, I don't know x. I know y was 3. I know z was 5, and that will equal 3. So multiplying, I have negative x plus 18 minus 20 equals 3. So 6 times 3 is 18. Negative 4 times 5 is negative 20. Combine my like terms on the same side of the equation. Positive 18 minus 20 would be negative 2. I need to get x alone, so I add 2 to both sides. That's 0. I have negative x equals a positive 5. And lastly, I need to get x alone. I divide by that negative 1. So x equals negative 5. My answer is an ordered triplet, right? So I don't just stop here. I want to give the final solution as an ordered triplet, which will be x, y, z. So x came first, which was negative 5. Y was 3. And z was 5. And there you go.